You're listening to Brainwave, the podcast that gets us thinking about the future of medicine. My name is Liz, and this is Ben.
Heyo!
Today we're going to skim the surface of precision medicine. So let's start from the beginning.
Since the dawn of time.
Oh my gosh, not that far.
Well, alright, we'll come a little bit forward. Since the start of medicine, there has been revolutionary practices that have evolved over time. And we think it's about time we checked in on some current technology.
So let's talk about that.
What is happening in the scientific world that we need to know about?
Recently, I've been reading some articles about a pretty interesting area in science. It's called neuroprosthetics.
You're what? So I'm picturing some kind of weird head with like a robotic arm that's like sticking out the side, maybe like a leg where the ear should be. Like out of 10, how close am I?
A little bit there. So it's a good try. In essence, what neuroprosthetics are tiny little machines that are implanted into a person's brain to treat something at the root.
Right.
In the brain.
So we're implanting a device into a person's brain to treat some kind of illness. It's like a little bit Black Mirror, don't you reckon? Like, how new are they? I mean, I haven't heard anything about them.
Yeah, well actually, neuroprosthetics have been around since the 70s. Pretty well-known example is the cochlear implant, and that first became commercially available in 1972. But the implants that we're going to talk about are a little bit different. They've been in use for around 30 years already.
Wow, I'm actually a bit surprised by that. So, what implant are we talking about today?
So it's called deep brain stimulation. And essentially it's this device that's made up of two little rods that are each connected to a pulse generator through some wires. A surgeon will implant each of these little rods into a specific part of the brain and place the generator just under the collarbone. So the generator acts like a pacemaker, and it sends electrical signals up to the brain, which then disrupt the firing of other neurons. This is what those neurons sound like.
Whoa, so that's going on inside my brain?
Yeah.
Like little bits of bubble wrap.
That's exactly what it sounds like. All those little pops that you can hear are actually the electrical signals that are being passed along your neurons.
Yeah, that was really awesome. But I mean, what does DBS do? Does it, like, stop the neurons from firing, or does it promote them to fire? Well, what's the deal?
Okay, so kind of. What we know is that DBS disrupts the signaling of neurons, at least in Parkinson's disease. But the trouble is that we don't know exactly how it works just yet.
Wait, so if you don't know how it works, then how do you even use it?
That is a very good question. So, over the past 30 years, deep brain stimulation has been used to treat Parkinson's. So, as the technology has progressed, some researchers and doctors have started using it, or trialling it, for the treatment of depression.
Well, I mean, I know a fair bit about depression studying psychology.
Oh.
Like that it's such a huge health issue that affects 1 in 16 Australians.
Wow.
And I think all of us know someone who's been at least somewhat affected by it.
Yeah.
But since it is such a big issue, aren't there already standardized treatments for it? Like, we learnt that the most common treatments are antidepressants and cognitive behavioral therapy. These are all quite effective, I think.
Yeah, I mean, they work for a lot of people. But since every person's biochemistry is different, not all drugs will work exactly the same way in every single person. So this is where the issue really stems. About 10 to 30% of people with severe depression are actually resistant to treatment. What I mean by this is people who have depression for an extended period of time and for whom conventional treatments don't really seem to work.
So that's quite a lot of people. So I'm guessing this is where neuroprosthetics come in. How do they actually work?
Right, okay. So, in treating Parkinson's, we suspect that there are certain abnormal signals that happen between neurons which lead to all of the typical motor issues that people with this disease have. What DBS does is it disrupts the abnormal signaling so that the neuronal signals can return to normal. And that helps to aid in the elimination of the motor issues.
So they reckon in a similar thing to how Parkinson's stops abnormal signaling, DBS can stop abnormal signaling in people with severe depression?
The short answer is that we don't know. Right now, the research in using deep brain stimulation in treating depression is very limited. But what I can tell you about is how electroconvulsive therapy works, which in a lot of ways is similar.
But I mean, it seems to me that the only similarities between the two is that you're just electrocuting your own brain. Like, what's the difference between getting zapped by electroconvulsive therapy or getting rods put it into your head and getting zapped that way?
I guess DBS isn't shocking the entire brain.
I mean, I guess DBS does seem to be more localized. But do you know how are they connected then?
So, research studies have shown that both electroconvulsive therapy and deep brain stimulation stimulate new cell development in the hippocampus. And this is important because the hippocampus is known to decrease in size in people with depression.
So theoretically, the same will occur for deep brain stimulation.
Yeah, you'd think so. But the effect would probably be more localized than electroconvulsive therapy, which theoretically also means that there's likely a smaller risk of big scale brain damage.
That's awesome. So it's like a fertilizer for the brain, stimulating new growth in the hedge of the mind.
Yep, that's it.
So essentially, we can change people's mood through sending small shocks into certain brain regions. That sounds awesome for scientific research, doesn't it?
Yeah, it's a really massive field to tackle the brain, right? It controls
It's the
all
magnum
of our
opus.
functions. It is the magnum opus. It controls all of our functions, but we don't know exactly how it works.
Right.
So that presents a little bit of an issue,
A little
right?
bit of a setback.
So if we could send signals into certain areas of the brain while someone is awake, which we could do because the brain doesn't have any pain receptors, we could start a massive investigation of what happens in what areas of the brain.
Wow. What I hear you saying is that we've still got a little way to go.
I think it's a long way to go. It's really important to note that deep brain stimulation is still quite experimental in its use as a treatment for depression.
And from what we've discussed, it seems as if it'll be a pretty long time before we know exactly how it works in relation to the brain.
Yeah, definitely. But, it's still crazy to think that the first computers were created in the 1800s.
Yeah.
And in only 200 years, we've managed to make them so small that we could fit them inside our bodies.
Squidge it all in the squidgy brain.
I think it's pretty interesting to speculate about how much further we're going to be able to go in the next 200.
Well, until then, tiny computers that shock our brains sound pretty mind-blowing.
We'll catch you next time
On
Brainwave.
Brainwave.